The operating system in Cisco Catalyst switches. Initially in its history, Cisco switches used an OS called Cat OS, short for Catalyst OS. This was an operating system from a company that Cisco purchased. When Cisco first got into the LAN switch business, Cisco routers used an OS written by Cisco, called Internetwork Operating System, iOS. Cisco made yet another migration to a different OS for Catalyst switches, this time to use iOS XE. To create iOS XE, Cisco took iOS and modernized the internal software architecture. iOS XE, often referred to simply as XE, has features to improve uptime and the ability to maintain devices without requiring rebooting, reloading the device. But it keeps the same familiar CLI. Accessing the iOS XE CLI. Cisco iOS software for Catalyst switches implements and controls logic and functions performed by a Cisco switch. Cisco iOS also defines an interface for humans called the CLI. The Cisco iOS CLI allows the user to use a terminal emulation program, which accepts text entered by the user. When the user presses Enter, the terminal emulator sends that text to the switch. The switch processes the text as if it is a command, does what the command says, and sends text back to the terminal emulator. The switch CLI can be accessed through three popular methods: the console, Telnet, and Secure Shell, SSH. Two of these methods, Telnet and SSH, use the IP network in which the switch resides to reach the switch. The console is a physical port built specifically to allow access to the CLI. Console access requires both a physical connection between a PC or other user device and the switch's console port, as well as some software on the PC. Telnet and SSH require software on the user's device, but they rely on the existing TCP/IP network to transmit data. Cabling the console connection. Cabling the console connection. The physical console connection uses three main components: the physical console port on the switch, a physical serial port on the PC, and a cable that works with the console and serial ports. Most PCs today use a familiar standard USB connector for the console connection. You have to look at the switch to make sure you have the correct style of USB connector to match the USB console port. When using the USB options, you typically also need to install a software driver so that your PC's OS knows that the device on the other end of the USB connection is the console of a Cisco device. Configuring a terminal emulator. After the PC is physically connected to the console port, a terminal emulator software package must be installed and configured on the PC. The terminal emulator software accepts the text typed by the user and sends it over the console connection to the switch. Similarly, any bits coming into the PC over the console connection are displayed as text for the user to read. The emulator must be configured to use the PC's serial port to match the settings on the switch's console port settings. The default console port settings on a switch are as follows: 9600 bits/second. No hardware flow control. 8-bit ASCII. No parity bits. 1 stop bit. Accessing the CLI with Telnet and SSH. Telnet and SSH both allow the user to connect to another device's CLI, but instead of connecting through a console cable to the console port, the traffic flows over the same IP network that the networking devices are helping to create. Telnet uses the concept of a Telnet client, the terminal application, and a Telnet server, the switch in this case. A Telnet client, the device that sits in front of the user, accepts keyboard input and sends those commands to the Telnet server. The Telnet server accepts the text, interprets the text as a command, and replies back. Cisco Catalyst switches enable a Telnet server by default, but switches need a few more configuration settings before you can successfully use Telnet to connect to a switch. Using Telnet in a lab today makes sense, but Telnet poses a significant security risk in production networks. Telnet sends all data, including any username and password for login to the switch, as clear text data. SSH gives us a much better option. Using Telnet in a lab today makes sense, but Telnet poses a significant security risk in production networks. Telnet sends all data, including any username and password for login, to the switch as clear text data. SSH gives us a much better option. You open a terminal emulator, connect to the switch's IP address, and see the switch CLI, no matter whether you use Telnet or SSH. The differences exist behind the scenes. SSH encrypts the contents of all messages, including the passwords, avoiding the possibility of someone capturing packets in a network and stealing the password to network devices. User and enable privileged modes. All three CLI access methods covered so far, console, Telnet, and SSH, place the user in an area of the CLI called user exec mode. User exec mode, sometimes also called user mode, allows the user to look around but not break anything. In this mode, when you enter a command, the switch executes the command and then displays messages that describe the command's results. Cisco IOS supports a more powerful exec mode called privileged mode, also known as enable mode. Privileged mode refers to the fact that IOS allows powerful, or privileged, commands from that mode. You can use the reload command, which tells the switch to reinitialize or reboot Cisco IOS, only from privileged mode. This example demonstrates the differences between user and enable modes. The example shows the output that you could see in a terminal emulator window, for instance, when connecting from the console. In this case, the user sits at the user mode prompt, certskills1, and tries the reload command. The reload command tells the switch to reinitialize or reboot Cisco IOS, so iOS allows this powerful command to be used only from enable mode. iOS rejects the reload command from user mode. Then the user moves to privileged, enable, mode using the enable exec command. At that point, iOS accepts the reload command now that the user is in enable mode. The commands that can be used in either user, exec, mode or enable, exec mode are called exec commands. Password security for CLI access from the console. A Cisco switch, with default settings, remains relatively secure when locked inside a wiring closet, because by default, a switch allows console access only. By default, the console requires no password at all, and no password to reach enable mode for users that happen to connect from the console. The reason is that if you have access to the physical console port of the switch, you already have pretty much complete control over the switch. However, many people use simple password protection for console users. Simple passwords can be configured at 2 points in the login process from the console, when the user connects from the console and when any user moves to enable mode, using the enable exec command. Cisco switch CLI commands. These commands is the key to managing real-world networks. Here is a list of the most frequently used and critical commands for configuring and verifying Cisco Catalyst switches, organized by task. 1. Global commands, initial setup and management. Pause the video to review this command list. 2. Interface configuration, ports, speed, and status. Pause the video to review this command list. 3. VLAN configuration, access ports and trunking. Pause the video to review this command list. 4. Verification and troubleshooting, show commands. Pause the video to review this command list. These commands cover the essential tasks of setting up a new switch. I highly recommend practicing the commands in sections 3 and 4 in Packet Tracer, as they are the core of VLAN administration.